With this demo, we're going to cover a use case that's been growing more common among our client base: how to migrate a SQL Server database on a Windows or Linux virtual machine to Kubernetes. We'll be leveraging DxEnterprise's unique capability to create a mixed cluster containing native and containerized instances. After that, migration can be easily facilitated with SQL Server database mirroring. To start, I want to show you the environment that we have here. I have a node named Win1, which is a standalone Windows virtual machine running on my workstation, and it resides in a completely separate network than the Kubernetes nodes. The only thing that's been done to this node so far is that DxEnterprise has been installed and the license has been activated. So this is a standalone node. And then what we're going to do is we have a SQL 2022 instance installed, and I'm going to go ahead and add a database to this. And this database will be used later to show the migration of a standalone Windows database to a Kubernetes environment. Next, I'm going to jump to an SSH session. This is connected to the Kubernetes master node. I'll show you the cluster here, which is 3 nodes all running K3s. Another thing that's been pre-configured here is a Kubernetes secret. And this secret contains the cluster passkey for DxEnterprise, and it contains the SA password for SQL Server. Keeping it in a secret makes sure that that information never has to be exposed externally. Now I'm going to add our Helm repository from our GitHub page. And this has already been added, so it'll say that it already exists. I just wanted to show that step. And now what we need to do is grab the values.yaml file from our repository, and we're going to copy it to a local file. And now we're going to edit that file. We want to make sure that we set our secret key to the key that we already created. We want to make sure that we accept the EULA for Microsoft SQL Server. Apply a license code for DxEnterprise. And then we need to accept the EULA for DxEnterprise. Save that file. And now we can go ahead and kick off the Helm installation. This command, it's the Helm install command, and I'm going to name this installation demo. It's going to point towards our GitHub repository, and I'm going to pass in that values.yaml file that we just created. And now this will go ahead and kick off the deployment. Now that the deployment is complete, we can see our pods by running the kubectl git pods command. We see that we have 3 pods up and running. And now we need to view our services so that we can get the external IP address assigned to the pods by the load balancer, which in our environment is metal LB. Now we can use this external IP address, so 10.2.282, to connect DxAdmin. And we use the passkey that we assigned in the Kubernetes secret. And now we have a 3-node cluster. Each of the nodes is one of the pods in Kubernetes, and we have an availability group created, and all 3 of the replicas are connected to each other. So now we need to create an OTPK so that we can join the Windows node to this cluster. And the OTPK is a one-time passkey. The OTPK uses the DH2i matchmaking service and allows the nodes to find each other on the public internet, authenticate using the OTPK, and then create direct encrypted tunnels with no middleman. So create a new one, and then we'll copy that. back over to our Win1 node, and then we can use that OTPK to join it to the Kubernetes nodes. Now the join is complete, and we can see that our Win1 node has joined the same cluster as our Kubernetes pods. And now what we can do is go ahead and add it to the vhost for the availability group. We need to select our instance name, and then we need to authenticate to the instance. And then just select OK. Once the Windows VM has fully synchronized with the Kubernetes pods, we can go ahead and right-click on that node and say Start Hosting on Member, and this will promote that node to be the primary replica for the availability group. Then we just wait for it to connect and come online again. There it is. And now we can add that database that we created at the very beginning of this demo. So we go to Manage Availability Databases, we select our DB1 and click Submit. And now we just wait for the database to be seeded and to synchronize to the other replicas in the availability group. Okay, now that database is synchronized and healthy, so we can move the availability group back to our pod 0 in Kubernetes. We just right-click on the node and say Start Hosting on Member. That will move the primary replica back to pod 0. Now that the database is synchronized and healthy again, we can go ahead and right-click on Win1 and say Remove Member. And then we can also remove Win1 from the cluster completely so that it can be decommissioned. And that completes the migration from a standalone Windows instance to a Kubernetes environment. Now I want to show you automatic failover capability of DxEnterprise by deleting the active node. So our current primary replica is pod 0. And we'll see that the pod goes down and that the availability group automatically moves over to the second host. And because this is part of a Kubernetes stateful set, Kubernetes will go ahead and redeploy that pod. It will automatically rejoin the cluster, and then it will become an available replica again for the availability group. And there we go, the database is synchronized and healthy again. With that, this demo is complete. Please reach out to info@dh2i.com with any questions that you have. Thank you.